So my name is Mike Yeager. I'm the Director of Applied Technology for a company called vScenario. We're going to be talking about the virtualization of electric substations, modeling substations, and all the applications that come from that. So I want to talk you through the process that gets us there, how you go from having nothing to having a very robust 3D model of your substation, and then most importantly, how you actually use that data to do stuff, to solve problems. You know, we always say that data by itself is meaningless, it's just numbers. We've got to turn that data into information, which solves problems, drives decisions. So we'll talk a little bit about security. That's where we spend most of our time, but there's a lot of applications for these 3D models, so we'll look at some different ones. So yeah, we're going to, again, want to walk you through the process of how you go from nothing to something. And so that's acquiring data, fusing that data together, storing that data, and then using that data. So we'll start with how we acquire the data. So when we go out to a site, we gather large amounts of spatial data. We use a lot of different data acquisition techniques. We use scans from a drone, from a UAV. We use terrestrial laser scanning, which is a ground-based imaging technique. We use ground-penetrating radar to also spatially characterize everything below ground. We also have some 360-degree photography, which is sort of an ancillary output of the laser scan. I'm going to kind of walk you through each one of these methods and how they work and what we get out of it. So let me frame this up really quick. So what you're looking at is the output of a UAV scan. Okay, so all these green dots you see are where a drone has acquired one single high-resolution photograph. Okay, so the flight of this drone is very, very prescribed. It's a very particular altitude, very particular percentage of overlap. All those parameters are designed. The drone is flown autonomously in sort of just a snaking pattern, just periodically snapping these photographs. And then we use a technique called structure from motion, which is an image processing technique. And finding like features in those images, we can actually digitally reconstruct a 3D model of that site, which you'll see here in just a second. So the photographs of the drone are above, and then there's a digital recreation. This is what is called a point cloud. It's exactly what it sounds like. It's a big cloud of points. Every point has a position and a color. And so that is the output of this drone scan. And so every single one of these data acquisition methodologies has its own strengths and weaknesses. So this drone scan is very, very effective at capturing the terrain and the topology. Okay, and the other great thing about using the drone is it is a very, very non-invasive data acquisition technique. We don't even need site access. We can just fly the drone from outside, which is great for a lot of just the logistics. And it's also very, very fast. Okay, all this data was acquired in probably 45 minutes and processed overnight to produce that model. But then we also want to supplement. The UAV scan is not as good at characterizing all the little nooks and crannies of the substation, all the above ground components. So we supplement that with terrestrial laser scanning. What you're seeing, all the circles that are kind of flashing in and out, is where the laser scanner was positioned. And now you can see kind of the output of that laser scan. It's very, very dense, very, very robust spatial model. And so what we want to do is bring those two models together, and that gives us a full spatial characterization of everything above ground. And again, as I mentioned, one of the sort of ancillary outputs of the laser scan is just 360 photography, which is great. Everywhere you took a laser scan, you have this 360 photograph, which is very useful for being able to be there without being there, if you know what I mean. And then lastly, we also want to know what's going on underground. And so we'll employ ground-penetrating radar. We'll procure the as-built and reconcile the as-built with what's going on from our ground-penetrating radar study. And then we model all of that into our model. So now we want to bring not just the above ground stuff, but actually in our model have everything above ground, but also everything below ground. So all the utilities, all the sewer lines, you can kind of see how that fits into the model here. All the sewage lines coming out, or the stormwater lines coming out of the site. So we have this incredibly dense, incredibly robust model of everything above ground, everything below ground. And now what we want to do, so we've acquired all these different data sets different ways. We've done the drone scan, we've done the terrestrial laser scan, ground penetrating radar. Now we need to amalgamate that data. We need to fuse all of that data together. And that is the data fusion process. And so in order to do that, we need to get everything on one coordinate system. Okay, and so we do that with just traditional surveying. We have a handful of visual ground control points on site. What that allows us to do is map all of these data sets to one singular coordinate system. Okay? And you'll see here, I want to just kind of show you the output of what that looks like at the very, very end. So you can see these are incredibly dense, incredibly realistic models, and very importantly, they're very, very accurate. Every single nook and cranny of the site is spatially characterized, and now you have this sort of ground truth digital twin as-built of your site. And you can use this for all kinds of different things, which we're going to talk about here in a second. But again, it's hard to understand how important it is to be able to have this as a design canvas, this digital model that is an exact spatial replica of the site, both above ground and below. I'm going to skip over the data storage and come back to that. Let's look at some of the applications. So again, we do a lot of, we're one of the nation's leaders in SIP program implementations. We do a lot of design work and construction management work around those types of programs. But there's also a bunch of other applications for these kinds of models. I want to make sure we touch on all that. So sort of an obvious low-hanging fruit is safety and training. Okay, so you have this model, this exact digital replica. And what we can do is very, very simply put people in virtual reality to explore that model, okay? And so just imagine how powerful this is for new hires, for vendor onboard. Let's say you're going to have a contractor that's going to be out on site performing some work in a couple months. Well, you can actually put them in the site that they're going to be doing work on virtually. They can walk around. They can plan logistically how they're going to do things. They can get acquainted with all the safety hazards on site. Imagine, substations can be very, very dangerous places. Imagine new hires being able to explore a substation virtually, get acquainted with all the hazards, understand the dangers without actually being in harm's way on a substation. So there's some very, very powerful safety and training benefits using these models. And again, there's nothing else to it. Once you have this model, then it's just as easy as putting somebody in there and building sort of a training curriculum around it. We also work with utilities to develop sort of emergency scenario training type protocols where, kind of putting somebody in duress in an immersive environment, saying, hey, you have 4 minutes to go into the control room and route power from here to here or whatever. And the person being trained would go into that control room virtually and say, okay, I need to push this button, turn this knob, pull this lever. And they can be scored on how well they did. Did they follow the appropriate protocols? Did they do things out of order? And so it's a very, very effective way to train. Rosetta Stone, anybody know the language learning platform? They made $1 bajillion because they just used the science that immersion is the best way to learn anything. And so that's the goal here, is to put people in an immersive environment virtually that allows them to be trained more effectively. Okay, so that's safety and training. I'm not going to spend a lot of time on operations and maintenance, but I think that's fairly obvious. Being able to have this digital model that you can just open up and pull any dimension you want to on site. Again, these models are to a very high degree of engineering accuracy. We can pull any line height, anything you want to, just from the safety of your computer. Don't have to wrangle a bunch of people together to go do a site walk. So when you're planning any operation and maintenance activity, this is a very, very useful tool. And then jumping into security. So again, we do a lot of SIP, perimeter security hardening implementations. But even before you get there, just having this model in itself is of great value for physical security, because it's this virtual tabletop. Any physical security person will tell you how invaluable a tabletop model is. And historically, they're actual models on a tabletop, like with little miniature components and stuff. And so this is a virtual tabletop that allows security folks to fly around the model, zoom around, walk through it virtually, being able to. So a lot of imagine that you're going to have a new security protocol that's going to be rolled out fleet-wide, okay? And it's important to understand how this security protocol is going to affect all of your different substations. So being able to pull, maybe some of your substations are in very, very urban environments. Maybe some of them are way out in the sticks, very, very remote. And being able to pull them up virtually without having to drive all the way out there, get everybody together for a big job walk, virtually pull all these up in a conference room on a big TV, fly around, visualize, chat things through, make decisions. So that even just having the model and exploring the model in and of itself is a very valuable physical security exercise. But really, where we as a company spend most of our time is using this model for design and construction activities. And again, we do a lot of this with perimeter security upgrades, modeling in the entire perimeter security system. So I'm going to start with the virtual design. So if we look here, I want to get you guys kind kind of seeing. So again, what you have here, what you're looking at is a 3D model of the substation. Okay, the existing conditions, and that's where you see the terrain, all the components over there on the left. But then on the right, what you're seeing is a virtually constructed perimeter security system. So every component of the security system is virtually constructed and put into the model. So the barrier system, access control, camera, intrusion detection, all of that stuff goes into the model. Okay. Now, I don't know if any of you have a construction background, but we use what's traditionally called BIM, okay, Building Information Modeling. And so all of these virtually constructed elements have metadata attached to them. So for every 8-foot section of fence, we can embed any kind of data we want into it, any kind of specs, but most importantly, all of the cost data, okay, the installation costs, the material costs, the maintenance costs, especially when we're talking about some of the technology components. And so all of that data gets embedded into these virtually constructed elements. And so when we have this virtually constructed security system, we have all of the costs associated with it. We have all the true life cycle costs. So not just the material costs, but the installation costs, the maintenance costs. And this is, again, remember, this is very, very early in the design phase. So this is not built yet. This is virtually constructed. And so we can then conduct all of our design reviews virtually. And this has really revolutionized the way that this process happens. So before it was, this very serialized process where we'd get everybody together for a job walk. We'd go do the job walk, got to get 20 people's calendars all synced up. And then when we do the design review, we just sit around a conference table with paper plans and just look at everything in 2D with highlighters marking stuff up. Well, now, as we're designing, we can periodically get everybody together virtually from anywhere in the country, just hop on a Skype call or a WebEx or whatever, and conduct these walkthroughs virtually, okay? So kind of see what this looks like. So we will virtually walk the sites with the owner, with the security team, with the engineers, and be able to address all these design issues in real time virtually as we're going along. And so you'll see kind of all this signage that we virtually stick up, and that's kind of where there's some different issues that we'll literally walk to that issue, and everybody will look at that issue, address that issue in real time. So, and again, we model also the interior of the control house, which is very, very important, and being able to, space is always, real estate in these control houses is always such a premium. So being able to have this as-built model that then you're designing to, and we can walk through and see where all these new components are going to go and where they're going to be mounted on the walls and whatnot is very important. So this virtual design review process has been it's been very exciting. Okay, so we when we kind of first rolled this out, it was very just kind of a lot of silence on the other end when we were with our owners, just kind of trying to figure it out. Like, not sure if I can trust this, but it's been very, very cool to see. Now all of our design review sessions are these very, very interactive. You have people, and even anybody can say at any moment in time, hey, again, this is a complete model of the site. We can say, hey, can we actually go to the south end and look from the east to the west? I want to see how this gate, and da-da-da-da. So being able to do all that stuff in real time has really revolutionized the way these design review meetings are run and conducted. And like I said, it's been very, very encouraging to see that now all of our clients are very, very engaged and interactive with this process, which is very exciting. So, and then, as mentioned, we embed all of the cost data into this model. And so as we build out the construction schedule, the sequencing schedule, we can run these simulations to give owners an idea of their cash burn rate, which is a very, very important metric from an accounting perspective to be able to track cash through the sequencing of construction. And it's also a very, very powerful accountability tool where you can say to your contractor, hey, Mr. GC, this is where I'm supposed to be today, and that's not where I am. How do we get caught back up? And then specifically around security from a technology design perspective, one of the other very powerful things is because we have this as-built model, we can virtually assume camera views and see what cameras are going to see before they're installed. So you see we're going to go down to this camera here in the southeast corner. And again, this is part of our design review process. So we're just on a Skype call with the security professional for the owner, and he says, hey, I would really like to see a little bit more of the interior of the yard, a little bit more of the exterior of the yard, and we can just literally move that camera virtually in real time until he says, right there, that's what I want to see. And so now we have all of the installation parameters for that camera, the height, the down tilt angle, the azimuth angle, focal length, all of those specs perfectly dialed in so that when it goes out into the field to be installed, there is no guesswork. You have the cameras that are going to get installed and see exactly what you want them to see. And then this is probably the most important slide, is this is just a better way to do it. So we've rolled this out with several major utilities in the United States and seen some really, really great results. So what we've done is we've taken what was traditionally up at the top a very, very serialized process. First this, then this, then this, then this, and then if something messes up, well, crap, we've got to go back to step 2 and keep running through it all over again, right? And we sort of, using this technology, we've deserialized this process and sped it up tremendously. And it's hard to understate how powerful being able to just visualize stuff is, being able to see it, where you're not looking at paper plans. And so this has, for our clients, decreased their design time, their design timelines by about 30%, and time is money, so it's also decreased their design costs by 30%. And because this is a better way to design, it's also a better way to build, and so it's decreasing the installation costs by 8 to 10%. Okay, so massive savings. One of our clients in the Midwest is the $1 billion SIP program, and it's saved them. Doing it this way has saved them $236 million. Okay, so a lot of cost savings. Very, very effective way to do things. So, and what we are encouraging is, again, as you can kind of start to see, these models have a tremendous value outside of just the perimeter security upgrade. Okay, and so we are encouraging the utilities to use your SIP program, use your facility enhancement program as a sort of a reason to acquire all of this data. Because again, we and other designers will use this data for designing the system, but then you have it. You have this exact digital representation of your site onward and forevermore. And so we're really encouraging utilities as using their SIP program as a mechanism to acquire this data, use this data, and begin to virtualize their substation. And then lastly, I want to go back to what I skipped over, to storing this data and disseminating this data. And this is very important. So one of the great tragedies is using all of this data. I mean, you can see just how robust and awesome these models are. And they're being used for a very specific thing. They're being used for this design program for the facility enhancement or for security upgrades, whatever the case may be. And then it just dies. It's served its purpose, and the data is no more. Okay. And traditionally, these, as you can imagine, these data sets are very, very big. They're very, very heavy. And so the utilities don't have, traditionally, like supercomputers with souped-up graphics cards and technicians who know how to work with these kinds of data sets. So being able to disseminate this data and make it useful, ongoing and forevermore is something that's just not really happening. And so we wanted to solve that problem, and so we have a software platform called SiteSpy that's a web-based viewing portal for these kinds of data sets. And so it requires no special, no technicians, no software geeks, no supercomputer. You can just open up Google Chrome on your Dell laptop and explore these data sets. So this kind of shows you what it looks like. So just imagine having all of your critical assets, all your substations in one place, being able to search them, sort them, and find a particular one that you want, and jump into all of the data that was acquired. So this is the 2D aerial photography from the drone that can be explored just kind of like Google Maps, but it's very, very, very high fidelity. I mean, you can zoom in and see a Doritos bag on the ground if it was there at the time of acquisition. And again, this is an engineering map, and so we can do takeoffs on the fly, make notes, send quick little notes to colleagues. Can also digitize and overlay all of your engineering drawings. So this is a way to centralize and digitize all of your plan sets, so you don't have all these paper as-built rolled up in the closet. Everything is in one place, digitized, and able to be shared and disseminated. And then most importantly, being able to explore this 3D data in a really, really meaningful way. This software application just allows anybody, you don't have to be an engineer with a supercomputer, just on your Dell laptop, be able to hop in and explore, pull measurements, fly around, visualize, discuss, being able to pull this up on a big screen TV in a conference room and just kind of talk through an upcoming maintenance activity. Anyway, so the goal, again, is to get the most life out of this data as possible. And so storing this data and disseminating it is just as important as acquiring it and using it for whatever the original task was. So that's it. I'm going to be around all day, and got some business cards out on the registration desk, but look forward to meeting some of you later on, and thank you for your time. Any questions?
I wanted to ask you how you virtualize the equipment inside the substation control house, and,
Sure.
and is it accurate to make model?
Yeah, exactly. So that's also just done with terrestrial laser scanning, and so yes, it is highly accurate, and every little knob and switch of the control panel is captured, and so we can. The other important thing is that there's different levels of detail sort of that we can do. If we just laser scan, you have this highly accurate model, but there's not a lot we can do with it as far as interacting. But we can also go as far as actually modeling out all of those control panels if need be, if we're going to do kind of like virtual scenario type training programs. So yeah, the control rooms are all originally acquired by the laser scanner, and then we can choose to take that up and model it out if we want to. Yes, sir.
In terms of handling configuration management, okay, it looked like that today, but in 6 months it's not going to look like that.
Sure.
How do you, is there another fly around that you can do to clean it up?
Yeah, no, that's a great question. So yeah, that's an obvious, that's a great point. So substations change. So we have this exact snapshot of the geometry of the site right now today, but yeah, what if you had a transformer? What if some kind of expansion? So the good thing about having all of this mapped originally to one coordinate system is that any other spatial models are just plug and play. And so we can, let's say that on the southeast corner of a substation, we've just done some changes. Okay, well, we want to make sure we get that into our model. Instead of having to start over and do ground penetrating radar all over again, fly the drone again, do the laser scanning everywhere, we can just deploy the laser scanner right there, fly the drone right there, and that all gets mapped to the exact same coordinate space. So great question. That's a really good point. Anybody else? All right. Well, cool. Thank you guys so much for your time.